Good day and welcome everyone. Today's webinar is aimed at truck salespeople, bodybuilders and transport operators, and will cover the basics of how to use our axle weight calculator. We have participants from Australia and New Zealand. Thank you for taking the time to join us. We look forward to answering your questions and getting some feedback from you later on. My name is Martin Damon, and I'm joined by Jens Halberg, Managing Director of TruckScience, and also by Tony Hodges, our TruckScience agent in Australia, who's based in Melbourne. Tony, hi, good morning. I'll give you an opportunity now just to introduce yourself and to make everybody aware of the services that you offer to the users in Australia. So Tony, over to you.
G'day Martin, Jens. A lot of people would probably recognise my name, but obviously we've got Australian support here. So, I mean, my background is in the engineering side of trucks and heavy vehicles. So if, you know, like we're not just basically computer people, if you need some help, we've got Australian backup.
Okay, thank you, Tony. Here's a brief overview of what we'll cover today. We'll learn how to find a vehicle and customize it with the body, equipment, and payload. We'll also show you how to interpret all the information that is generated by the app, produce a report that you can use for sign-off with your customer, and in general, just show you how to get the most out of all the features that are available in the app. To demonstrate the features, I will take you through a live demo, and we'll do a sample calculation using a 6x4 Fuso truck, and we'll add a curtain side body and a tail lift. And we'll need to make sure that the vehicle is well balanced, not overloaded, and in the end produce a professional report. To log into the app, we recommend that you do this from our website. So if you just go to TruckScience.com, you'll find the login button, and to the right of that, the start free trial option. So if you're not a user yet, please come back to the website later on and register for a trial. Once we've clicked on login, the app will open to the vehicle selection screen. At this point, I normally like to select the full screen option. Again, this is particularly handy when we have the graphics of the vehicle on the screen. There are a couple of filters that we can use to find the vehicle for our exercise. I'll start off by selecting Fuso, and then we'll go through the fighter range. Axle layout will be 6x4, and we're left with a couple of options. To narrow down this choice a little bit further, we use the keyword search option. We could type in here, for example, air suspension, if we're specifically looking for air suspension, and I'll find that in the description. That narrows the search down even more. There are a couple of other useful filters that I can point out. You can filter between current and discontinued vehicles, or both. You can also filter on complete vehicles, prime movers, and just straight trucks. Some other useful information when you're in the list of vehicles is the vehicle code. So if you know your vehicle codes, you can even search on those. The wheelbase of the vehicle and the spec date. In this case, we'll use the vehicle with the spec date of March 2017. I'll open the vehicle. You'll notice that it opens with the graphic dimensions and weights according to the spec sheet from the manufacturer. You'll also notice that we've got a scorecard at the bottom with all these green ticks. This is to measure the compliance with the regulations and with manufacturer ratings. So at any point, we want to keep an eye on the scorecard to make sure that there are no red crosses. So if any of these green ticks change to red crosses, we'll want to investigate that. To customize our vehicle, we can click on the menu options on the left. I'll just show you some of these. That's the vehicle menu. If you don't need to change any dimensions or masses on the vehicle itself, then we've got the body, different body types that you can add, equipment such as crane, tail lift, and then payload, trailer 1, trailer 2. To close these menu pop-up forms. You can click on the cross in the top right corner, or just click anywhere on the white space. There's another shortcut of how to get to the menu, and that is by clicking on the hyperlinked dimensions in the graphic, or even the masses in the weights table. To give you a quick example, I'll click on the wheelbase. That'll open the vehicle menu and highlight the wheelbase attribute. To make a change to that, I can select the override, increase the wheelbase, and watch how the dimension changes. I'll just move this pop-up form up slightly so we can click and drag that so that it doesn't obscure what we're trying to look at. You can use the tickers to perhaps increase the wheelbase, or if I wanted to go back to the default wheelbase, I can just deselect the checkbox and we'll return to the standard wheelbase. So that's another handy way of getting to the menu options. For our example, we won't make any changes to the chassis. We've got the right wheelbase and we have all the correct chassis masses. And note that the chassis mass in this case excludes fuel and crew. And for that reason, we add fuel and crew as a separate line item to give you a total unladen mass. To see the details of fuel and crew, I will go to the top right corner and select one of the view options. So by default, we're always on the overview summary. And in this case, we'll have a quick look at the fuel and crew view, where you can see that we have 400 liters of fuel added to the chassis mass and one crew member at the front. To toggle back to the summary view, I'll click on overview and back to summary. Further at the bottom of the weight masses table, there's the permissible ratings. If you click on, for example, the front rating of 6,000 kilograms, it'll show you how we calculate this value. So we have the axle capacity at 6,000, suspension capacity, tire capacity, and the regulation. And the lesser of those will give us the permissible. So 4 ratings and the lesser of is the permissible. I'll just close the menu pop-up again. Now it's probably a good time to add our body. I'll go to the body menu. A couple of standard or different body types that we cater for. If you don't find the body type that you're looking for, you can also look under other. That's a bit of a catch-all for bodies that aren't listed specifically. For our example, we'll add a curtain side body. Now there are a couple of different methods that we can apply to adding a body. We can either add a template curtain side. So we can add a template, and you'll notice that there are different filters here. So a template is identified by this icon, and then items in the public library, you'll see have a slightly different icon. So if I click on template, I'll only see the templates. If I go to public library, I'll only see the items that have been published by, for example, bodybuilders to advertise their products. If I go back to all, I'll see a mix of template and public items. The third option is to import a DXF. This is particularly handy for bodybuilders and allows you to bring in your exact drawing of your item and to advertise it to all the other users of our software. I'll start off with a template, and I'll highlight some of the advantages and disadvantages of the different methods of adding a body. So template body, by default, we'll just assume the chassis length and the default height. The advantage being that we have full flexibility on changing dimensions from internal, external, subframe, and also the mass of the body. The disadvantage is perhaps that there are quite a few attributes and it can be quite consuming to specify all the attributes. For example, if I want to change the vehicle length or the body length, we can click on the overall length at the top. That'll take us to the body length on the menu. Let's change that to 9,200. you'll notice in the background that the body length is extended. Just to show you a few features of each attribute, if you see an information icon, don't be afraid to click on these. You can always we have an undo feature, so if you make any mistake, you can simply click undo. So if you see something on the screen that you're not sure about, just click on it and it'll explain what information is required or what this attribute represents. This lookup book icon gives some indications of guidelines. For example, the available chassis length for the body length, the maximum body length, and the optimum body length. Let's pick the maximum body length to see what that'll produce. In the background, you'll notice that the rear overhang is now 3.7 meters from the rear overhang line, and that's the maximum legal limit. If we go back to the lookup, we can also select optimum or back to available chassis length. All right, so those are some of the features of the template body. You can change all the length attributes, for example, headboard thickness, tailboard thickness, the height, subframe height, the height of the body itself, and you can also specify whether you'd prefer to input the dimension as the external or the internal dimensions. The width of the body, in this case, assuming the rear width of the vehicle, can be changed to 2,500. Then the mass of the body is on a separate tab. Again, we have a default for the mass per running meter. That can be changed to specify an absolute value. For example, we can toggle that to kilograms and specify 2,200 kilograms, or if we 2,200. Or if we prefer to stick to kilograms per meter, we can also look up some guidelines on different materials, floor types, and different sort of industry average masses per running meter of body length. The position of the body is something we can change on the tab at the top. The position of the body is measured from the back of the cab. We can either do this by overriding the default and moving the body back, or a very handy feature here is to actually drag the body. So I can click and drag the body, and as I move it back, notice how it changes the weights in the masses table at the bottom. So I'll just do that again. I'll drag it quite far back until I trigger a warning on the scorecard. The warning indicates that we're not compliant on dimensions. If we're not sure what the error is for, we can go to the notes and warnings on the right, click on the warnings tab, and it will explain that the rear overhang exceeds permissible maximum. So we'll have a look at that dimension. There it is. It exceeds the permissible maximum, which would be 3.7 meters. So we'll drag the body back, or we can use the undo feature. So if we click undo, it will just step back to the position that we had originally. I think that's probably enough for the template body. Maybe just to show you the overall height, I'll click on the height and just increase the height. And remember, you can always drag this pop-up form so that it doesn't obscure the graphic where you're making the change. Let's remove the template body and replace it with a manufacturer product from the global library. So to remove this template curtain sider, you can click on the scissor icon, remove this body, and then we'll select from the curtain side option or we'll leave the item from the global library for last. And maybe at this point, I'll show you the import feature for a DXF file.
Martin, just to point out, there has been a question about importing DXFs and who that DXF might be accessible to once it's imported. So maybe just while you're doing that, you can point out what your options are in case other people want to know.
All right, I'll do that. So to import a DXF, we have put together a nice easy wizard to follow. We'll choose a file. In this case, I've got a file under my documents, austruck.tortliner.dxf. Now that DXF will not be made available to any other users of the software. We convert this file format into our file format and only show the side view two-dimensional graphic. If some pointers on the DXF file, the file needs to be less than 1 megabyte in size and just be a simple two-dimensional drawing. If there are unsupported objects in the file, we will just truncate them from the import. Okay, that's what our body looks like. Click on next. Here at step 2, we can position the body at the required 0, 0. So I'll drag it down to the 0, 0. Next. Then we can adjust the length and the height to, in some cases, the default scaling wouldn't be exactly in millimeters. So that can be adjusted. For example, I can override the length and say this body could be, for example, 9 meters long. Sorry, 9, let's make it 9/200. Make it a little bit longer, and that'll adjust the height and keep it within the aspect ratio. There are quite a few attributes to populate. I'll just populate the basic ones. I'll show you height. There's a height. We can populate substructure height, roof thickness, width. Width will be an important one. We'll make the width 2.5 meters. We'll go next. The body mass could be 2,000 kilograms. We can adjust the center of gravity of the body itself and the payload. And we can also toggle between specifying that as a percentage or in millimeters. So if we toggle to millimeters, it'll show the horizontal center of gravity of the body from the front to where it's shown on the graphic. Toggling that back to percentage, 50%. Next. We can give this our own description. This is my body. And it will be saved to my personal library. Save and add. Okay, so I'll come back to explaining the format of this file and the limited access that other users would have of that. Once we've customized the body and we would like to publish it to the public library, we can click on this option and then click on the save next to the body description. The save will give us the option to save this body to either only my personal library, in which case nobody will see this drawing and nobody will have access to it. You can share it with your team. That means only your colleagues will have access to it. Or you can allow the wider TruckScience community to have access to this body. And in that case, we will then publish it. We will review your body and publish it so that all the users of our software have the ability of adding your body to a chassis. They will either, as I mentioned, not have access to the original DXF file. Let's select OK. We'll keep it in the personal library. Your request has been submitted. Somebody from support will get in touch with you to make sure everything is right for us to distribute the body to all our users. I'll show you again, if we remove this body, how to re-add it. So because we've now saved it to our library, I can go to my personal library under body and I'll find my body here. And I can just re-add it. That's everything for the body feature. At this point, maybe check if there are any questions, or if you'd like to ask a question, you're welcome to raise your hand.
Yes, there's another question about the offset where the body is placed, and Stephen wants to know, how do we? Well, Tony's explained that that the offset is specified by the OEM if it has been provided, and Stephen just was querying, how do they know whether it's been provided by the OEM or not?
Okay, that's a good question. I'll just go back to the position of the body, In this case, the manufacturer has given us a default minimum cab gap of 130 millimeters from the back of the cab. That, if to answer the question, how would you know if it's provided or not? If this value is 0, that would indicate that the manufacturer has not given us a recommended minimum. So 0 would indicate that. Anything greater than 0 would indicate a dimension supplied by the manufacturer. Okay, so if I untick that, the default cab gap is 130, or we can make it bigger than 130. So if, for example, we made it, say, less than the manufacturer's recommended, let's say 20 in this case, let's have a look at notes and warnings. The cab gap, there's a note here, the cab gap is less than the recommended of 130 millimeters. So the notes can be very useful to give you some indication of the assumptions that have been made.
Sorry, Martin. I'm just thinking that I think it would be useful if we could add that to the note on the body gap attribute. If you could just point out there on that info icon.
Yes.
If you expand that, I've made a note here, and what we'll do is we'll add that to the note and say if it's 0. You'll know that it's that it hasn't been specified by the OEM. So thanks for that feedback, Stephen.
Yeah. Okay. So I'll untick the override to go back to the recommended 130. Okay, body looks good. Right now we have just over 13 tons of payload, but we still need to add our tail lift. To do this, we'll go to the equipment icon on the menu and then select tail lift. Quite a few options here: aero kit, aerial platforms, toolboxes, outriggers, rear bumpers, or any other items. We'll select tail lift, and again we've got templates, personal ones in your own library, or items from the public library. Let's search for an Antio CL22. So as we're typing in, we'll filter down the list of public tail lifts in the library. Pick the first one, the Antio CL22C, which then gets attached to the rear of the body and vertically aligned with the floor of the body. If we needed to adjust the tail lift, we could click and drag it, move it up a little bit, and release it. If we think we made a mistake, want to go back to the default, we can just click on undo. Same principles apply to equipment as to the body that we added. In other words, you can add a template, a item from the public library, and again import a DXF. The payload has now come down from just over 13 tons to 12.5 tons because of the extra mass of the tail lift. That will obviously also affect the distribution. And by default, we optimize or maximize the payload. So if we click on the payload link on the body, that'll take us to the menu for the payload. So the default is a simple payload or a water level load, and it's maximized to 12,500 kilograms. If we override this value and increase it, it'll highlight the overload in the masses table. This could be a good example to show the difference between toggling the regulations. So we'll overload the rear axle slightly, and then we'll change the regulation. Remember, we've got air suspension, road-friendly suspension on the rear. So if we toggle from the Australian national regulations, we can click on the regulations and then select from the drop-down to go from Australia to Queensland or Victoria. And you'll notice we also have the New Zealand regulations in here. Let's toggle to the Victoria regulations, select OK. And you'll notice that the rear permissible increases to 17 tons, which brings us back to a legal value again. For this exercise, I will toggle back to the national regulations. and then just maximize the payload again. So undo the override and go back to the maximum. There are other techniques you can use to eliminate overload such as that. You can obviously, or let's try a few different options. If we overload that again. So to shift some of the load from the rear axle to the front axle, we could, for example, move the body forward, but we can't do it because that would be less than the recommended cab gap. We could adjust the payload center of gravity forward. So if we move the center of gravity of the payload forward slightly, maybe in millimeters, and we move it forward by 100 millimeters, and you'll notice the center of gravity has just moved slightly forward of the center, and some of the weight has been transferred to the front axle, taking the overload off the rear axle. Dimensions, we still have a warning here that we are over the legal limit on the rear overhang.
Martin?
And that is, yes.
Can I just interrupt you there? There's another question there. Stephen has asked, when placing a simple payload, he tends to try to balance the front and rear axles, and he does this manually. Is there a simpler way to balance the axles or get all axles to 0 other than manually adjusting the COG?
You can do the optimum wheelbase. Yeah. Okay. Let me just show you. Before I do that, I've still got the imported body on here. I just want to change this to the exact body. I'll just remove the body again and change that to the one that has been added to the database by Austruck, truck bodies. And I'll go back to equipment to add our tail lift. Here, CL22. This body is slightly shorter than the 9.2 meter body that I had imported, and that ensures that we're within the rear overhang limit at the rear. Okay, so let's overload that again and try and balance that. If we will overload it ever so slightly, and then we can also, okay, we want to get the overload to 0 on both the front and the rear axles. All right, there is, yeah, I just have to think about this. There's an option of optimizing the body length, which is not possible on a manufacturer's product. The other option would be to change the wheelbase, if that is an option. In the case of the tail lift, the optimize on the wheelbase is not possible. But if we only had, for example, I'll just remove that tail lift again, and then I'll optimize the wheelbase. Select the vehicle menu, wheelbase, under the lookup, the optimum wheelbase 6330. So notice the wheelbase is currently 6.5. If we click on the optimum wheelbase, that will balance the load perfectly between the front and the rear axle. And if we maximize the payload again, let's just go back to payload, untick the override. That will give us a perfect balance between the front and the rear axle and the total, 6, 16.5, 22.5. So there is an option of doing optimum wheelbase. Does that answer the question? There are some limitations on the optimum wheelbase when certain items of equipment have been added, and we will improve that over time. It just becomes more difficult to calculate the optimum wheelbase when the tail lift is attached, because it creates a bit of a moving target there.
Yeah, Martin, just someone's asked there, when you add a tail lift, why would the payload COG not change to reflect the added weight at the rear?
The payload COG. Okay, let's add the tail lift again. The payload COG is totally separate to the tail lift COG. So we'll add the tail lift, NTO CL22. Tail lift has its own center of gravity. So the payload center of gravity is totally unaffected by that. We'd have to adjust that manually. We're assuming a water level load across the deck length. If I select the center of gravity view on the options on the right, summary, you'll see that the tail lift has its own center of gravity, which can be pinned, showing the center of gravity from the ground and from the rear axles. So when adding the tail lift, it will affect the payload because of the extra weight and because all that extra weight is hanging off the rear. We'll go back to this overview and summary. So to adjust the payload center of gravity, we need to do that manually. Horizontal, vertical, or lateral center of gravity of the body, of the payload in the body. Okay, let's have a look at the detailed payload option. So if we don't just want to assume a center of gravity for the payload, we can go to detailed payload, a couple of options again, template, items, your personal items, and items from the public library. Let's add a set of pellets. We've added some standard pellets to our database. In this case, we'll pick 14 pellets, standard size, 1165 by 1165.
Martin, Alphonse has asked whether you can demonstrate divisible and indivisible payloads. So I thought it would be quite relevant now, while you're adding these pellets.
Yeah, divisible. Okay, if we're adding this is a divisible load because you've got individual items. Indivisible would be something like a bobcat or a heavy piece of machinery, which I can show you and add it to this body as well. Let's reduce the payload for the pellets from 17,000 to about 12,500. And then we can still drag these pellets slightly back because we still have a small overload on the front axle. So we can drag the pellets to the rear and create a better distribution on the front and the rear axles. An indivisible load, before I go to that, I'll just quickly show you the top view. So if I toggle to the top view, I can also position the pellets laterally across the deck of the body. Back to the side view. Let's remove those pellets and replace it with an indivisible load. Let's take, for example, a bulldozer. Let's see what we have here. On the bulldozer, this would be a large piece of machinery, only one payload item with a center of gravity and a mass. And again, we could click and drag that item around. This would probably be more relevant on a prime mover with a low bed trailer. I'll remove the bulldozer and revert back to a simple payload. Does that answer the question there for Alphonse?
Well, it might be worth pointing out that kind of stack of 14 pellets can also be loaded individually. It just, obviously, for the purposes of our example, it just takes a bit longer to add the 14 pellets individually. So we've chosen to add them as a group, but you can add them individually and then divide them up across the deck.
I'll show you that quickly. Generic payload template. We'll add something like an individual pallet, which we could adjust. We can adjust the length, the height, the width. So we could make it 1165. The height might be 1600, and the width could be 1165. Mass would be 1,000 kilograms. We could save this item to the personal library, call it my pallet, and then duplicate more of these items. Click on add, go to the personal library, my pallet. We'll add another one over the first one, which we can click and drag and position it with a slight clearance if we like. Toggle to the top view and perhaps move it next to the pallet at the front of the headboard. So there is total flexibility on adding individual objects to fill up the body and then moving them around until you've found the best pattern for loading that vehicle. Go back to side view and toggle back to simple payload. I'm aware of the time, so I'll just move on. We've finished the configuration of the vehicle. We've got all the axles within legal limits. There are no warnings on dimensions. couple of views that I haven't shown you yet on the right. So the overview is the default, the bridge view or for the axle groups. This will probably be more relevant on a B double, which is an example we can maybe do in a later webinar. Center of gravity we've already looked at. Turning circle, smallest turning circle in regulation. If you want to have a look at the smallest turning radius with the inner steering at its maximum angle, just over 10.5 meters to the outer edge of the tire is the curb-to-curb radius, and the inner radius just over 6 meters. Toggling that to the regulation turning circle will show the steering angle that's required for the outer edge of the tire to be a 12.5 meter radius. And toggle back to the side view. And we'll have another look at notes and warnings. We've got no warnings and a couple of notes that we can read through. Okay. And in the bottom right corner, I'll just highlight this chat feature. This is probably the best way for you to get in touch with us if you need help with anything. You can click on, you can start a new conversation. You can say, "Hi, support. Please, can you assist me? How do I add a body or import a DXF?" And we will typically respond in a few minutes. And this is a live chat, so it's and I think some of you have already used it, and we really encourage you to make use of this. So we'll just wait for a response for that. Then the preview. Preview will generate a PDF document which can still be customized by specifying the customer's name and maybe telephone number, and then applying the changes to our PDF document. Your logo can be added to the top left corner. So if you haven't added, if your logo is not shown here, please email it to support@truckscience.com and we'll gladly add it for you. Here's our reply from Jens. "Hi Martin, how can I help you?" And that just shows you how the chat feature works. At the bottom of the first page, you've got the sign-off feature, so your customer can sign this to acknowledge acceptance of the calculation. Technical information about the center of gravity of the different items is on the next page, and then the notes and warnings on the last page. To remove one or two of the pages, we can, if we don't need all the technical information, we can deselect weight and center of gravity, reapply, and that will reduce the report to a 2-page document in this case. This final PDF can now be printed, downloaded to PDF, or emailed directly from our email portal. To give you an example of the downloaded PDF, I'll just download it to my downloads folder. Overwrite the one that's there, open it just to show you what it'll look like for your customer. If you attach it to a proposal, customer will be able to open it as a PDF document. To save the calculation, yeah, Jens, is there a question?
Yeah, Mon, sorry. There's a question that's come up about COGs, and I'm not, Neil's asked, can we provide a more detailed kind of breakdown of the COG rather than just the one COG symbol? And maybe if you could just point out, if I can't remember now whether you're still getting to that or not, but how you can pin certain COG dimensions and then set those in the PDF or display those in the PDF. Yeah, okay. The center of gravity view needs to be selected. We can pin all the individual center of gravity items. So we can see the dimensions and then select the preview. Does that answer the question? And the same principle applies: print, download, email. Okay, we've almost run out of time. I'll just show you how to save this calculation. Save it. We can give it our own description.
can call this horse truck body curtain sider if we like. Okay, to save it, we can save it as, to make a copy of the calculation if we wanted to make changes. So the save as option is there. The share option is there to collaborate with colleagues and bodybuilders. All you need to do is specify the email address of the person you'd like to share the calculation with. And I've already shown the full screen option. If you need to open the calculation from scratch or open a new vehicle, select the home icon on the toolbar. That'll take you back to the vehicle selection screen. From here, we can go down to, we can, for example, reset the search on the manufacturer vehicles. We can go down to vehicle templates, where you can design your own generic vehicles from scratch. Save calculations will take me to my list of calculations. Here's my horse truck body calculation, which I can just reopen. And make any further changes or adjustments, maybe save it as. Let's go back to home again. And I'll show you calculations that are shared with you will appear in the list here. And then request a vehicle allows you to ask us to add vehicles that are not yet in the library. So if you are struggling to find a vehicle, just specify make, model, and some notes. Submit your request. We'll be in touch with you. We have a fair usage policy on adding vehicles. So it's 1 vehicle per user per week. And we typically add a vehicle in about a week or 2. That's one of the services we offer at no additional cost. Okay, Jens, any more questions, or can we wrap up the presentation?
Yeah, I suppose there just to clarify Neil's question about the COG, if you could just maybe reopen the calculation that you've done and point out the center of gravity elements on page 2 of the PDF. That might also help them.
Okay, on page 2. Okay, so weight and center of gravity is the technical page. And we'll show a detailed breakdown of all the items. So the chassis, fuel tank, crew, the body, tail lift, payload shows a horizontal center of gravity, vertical, lateral, how it affects the front axle, rear axle in total.
Yeah, it's also worth pointing out, Neil had wondered about breaking down the payload into multiple COGs. So if you have multiple payload items, they would also be broken down individually in this listing.
Yes. Yeah. Okay. We'll go back to our presentation. And just carry on with a few more slides. So just in summary, what we've covered is showing you how to find the vehicle that you're looking for, adding body, equipment, and payload to configure the vehicle and to ensure that it's within the legal dimensions and masses, interpreting all the information, and generating a report that can be signed off by the customer. The pricing of the software, for those who are not yet customers, we have a tiered pricing structure, so additional users are discounted. First user is $60 per month, and additional users are $30 per month, so half the price. You can also opt for an annual subscription if you prefer, which also comes with a substantial discount. At the end of the session, I would encourage you to log in to the app if you're already a user and to try out all the features that we've demonstrated. If you're not a user, please register for a trial license. There's nothing to install, and your trial license is validated instantly. Our contact details again. If you need to get in touch with us, either use the chat icon if you need support, or if you'd like to talk to Tony Hodges directly For our Australian users, those are his details. For our New Zealand users, you can, if you want to get in touch with Sorika Grady, you can get her contact details here. Right, are there any more questions, Jens?
There are no more questions here, but maybe you know, if anyone has any more questions, feel free to jump in here. And also, any questions for Tony specifically?
Whilst you're thinking about your questions, we would love to hear from you and get feedback in terms of what we can do to improve these webinar sessions. We are planning on hosting more of these. Perhaps for the next one, we could focus more on specifics on center of gravity, or maybe the B-double combination, or a rigid plus dog trailer. So if you let us know what aspects of the software you'd like us to focus on a bit more, we can maybe take that into consideration for our next webinar. You can also send us suggestions of how to improve the app, any features that you'd like to see added. Please send those through. We prioritize features based on how many users request a feature, and we release regular updates, which then benefit all the users.
There's another question that's come through there about, is there enough time to step through adding a tag axle? So we certainly have the time. We can hang around for questions, and then if anyone needs to move on, feel free to just leave the webinar, but we can certainly stick around.
Yes. Okay, we can go back to the app. I'll share my screen again. So for those who are leaving, thank you for joining us. Stay safe and goodbye. For those who'd like to stay, please stay, and I'll spend a bit more time on that. Okay, so we'll do a lazy axle. We'll start at the home screen again. Don't need to save this calculation. Is there a particular vehicle, or is it? I'll just pick a 4x2 and add a lazy axle. So let's go back. Maybe take a Hino 500 series 4x2. Maybe there could be a specific vehicle, maybe a 2632. No, sorry, that was a 1628 extra long auto. Let's just pick a 4x2 chassis, and then we'll add a lazy axle behind the driven axle. To do that, select the vehicle icon on the left, masses and axles. You'll notice that flashing plus icon to add axles. So these are axle tabs. You can add an axle. You can add a tag axle. They'll give a default spacing to the tag axle, which we can adjust by clicking on the dimension, overriding it. We could make that 1350. Then we can go to the actual axle and the masses and axles, or we can click on the axle itself. The mass of the axle in this case is a very lightweight axle, 680 kilograms. If this is a dual tired lazy axle, that could weigh over a ton. We could make that 1,000 kilograms. By adding an axle, there are quite a few changes that take place even in the chassis mass of the vehicle. Adding a tag axle triggers a recalculate on the chassis mass. So the whole chassis mass is modified. So there is an effect even on the front axle by adding a lazy axle. So the original chassis mass, if I toggle to the front axle, was 3,603 kilograms. By adding the tag axle, it actually increases the front chassis mass slightly, in this case by say 40 kilograms. So just something to keep in mind, the effect of adding a tag axle or pusher axle, it has an effect on the front axle. Going back to the tag axle, axle capacity, we can specify as perhaps the same, if we wanted to, as the driven axle. So if we quickly have a look at the values for the driven axle, it's a 10-ton capacity axle. We could apply those same values to the lazy axle. 10,000 for the suspension, 10,000 tire capacity, and the regulation is limiting it to 6,000. It's possibly because it's only 2 tires. So if we go to tires, you can toggle from 2 tires to 4 tires to make a dual tire fitment. And then the regulation limit is automatically increased to 9,000 kilograms. You can override the regulation value, but it should actually be calculated correctly. I'll just change, I think, my axle capacity. I'll just change, because we changed the number of tires, it changed the axle capacity. And we could just change that back to 10,000 kilograms. Regulation is 9,000, which is the lesser of all of the above, and the permissible is there for 9,000. In this case, because the rear axle and the tag axle have the same suspension rating, that'll create a 50-50 split between the driven and the lazy axle. And the technical wheelbase, in this case, will be the same as the specified wheelbase. If the lazy axle has a suspension rating that is lower than the rear axle, which could be the case, especially if it was a dual tire fitment, or the suspension had a rating that's slightly lower, that's 8,000 kilograms, then that would have an effect on the technical wheelbase. Technical wheelbase moves forward slightly because the rear axle will be picking up slightly more mass than the tag axle, and that will be shown in the weights table here. So the rear axle rated at 9 tons, tag axle rated at 8 tons, and the rear axle carries slightly more weight than the tag axle. It'll be more obvious when we add a body. We will add that curtain side body again. The rear axle, okay, that wheelbase might not be the best wheelbase for this calculation. Probably want to reduce the wheelbase slightly. By reducing the wheelbase, we'll transfer more weight onto the rear axles and increase the payload. Okay, what we still need to check is the gross vehicle mass. That's actually the limiting factor at the moment, also highlighted by the blue. And we still have the gross vehicle mass set at 16,000. So for that, we can click on that 16,000 and change it. Gross vehicle mass would probably increase to either the sum of the axles or the manufacturer's limit, which might be 22,000 for the vehicle. We can probably increase our wheelbase slightly again. That looks about right. Okay, so adding lazy axles or tag axles is quite an advanced feature. If you do need assistance with that, you're welcome to get in touch with me, and I'll walk you through the process and just explain some of these more technical aspects, especially when it comes to things like technical wheelbase, axle, tire, and suspension rating.
Yeah.
Any more questions on that?
So there are a few more questions. Okay, so the one question is to whether we can work through a B double, but I was suggesting that we might deal with that in a later webinar, because it's probably slightly off topic here. There's another question there about, is it possible to modify the wheelbase on a trailer without it modifying the length of the trailer? And I suppose if we could just answer that question as opposed to demonstrating it. There was also a great a question there about whether we're planning to add optimum wheelbase for trailers. So I've made a note of that request, and I suppose it might be might be worth just explaining how we work this. We release new builds of the app every 8 to 10 weeks, based on user feedback, and the features that bubble to the top would be implemented first, and they bubble to the top by more people requesting the same feature. And maybe just a bit of insight into what's coming in the next release. We're doing a bit of work in the area of sharing calculations and managing calculations, so you'll be able to create folders in your saved calculations and just organize your work slightly better than you can at the moment. That's one of the features coming up.
Okay, so I think, Jens, you've made notes of all of that. I'll show you or I'll try and answer the question about changing the wheelbase without changing the trailer length. So I've added a hitch and a pig trailer, and when changing the wheelbase, the trailer length changes. So am I correct in assuming that you would prefer the trailer length to stay the same at that point? In other words, just moving the actual axle and not adjusting the trailer length. I think that was a question. Yeah, this is something that when we designed this feature, we weren't quite sure how to handle that, and it is perhaps something we can look into again to see if we can keep these two dimensions independent of each other, rather than a change to the one triggering a change to the other one, because that is probably what's causing the confusion. So Jens, if you can also just make a note of that. I suppose the downside to fixing the trailer length would be that the rear overhang then is adjusted automatically. There's always one dimension that needs to be adjusted. It would either then be the overall length, or it would be the rear overhang, and it might be more acceptable for the rear overhang to change than for the overall length of the trailer to change. Okay.
Yeah, I suppose another thing just to add there is we are also consulting with Tony regularly, just to and he's advising us on how to make the software more Australian, and you'll notice things like the state regulations dropping in and things like that. So we always keen to hear how to improve things. So please do let us know if via the chat. We'd love to hear from you via the chat in the app, or the chat here in the webinar, that is.
Okay. Right, is that it for the questions, Jens?
Yeah, it looks like that's it.
Okay, so look out for our next invitation to another webinar. And once again, thank you for joining us. Stay safe in these unusual times, and goodbye.